Hey, hi guys. Can you please confirm? I'm audible? Just let me know once in a chat, everyone.
Yes, sir, you are audible.
Okay, fine. Thank you. So let me share my screen and then we can start. And yeah, like I will upload the previous recording, like the study recording after this particular session. Okay, so that you guys can just go through it one by one. Okay,
Yes, sir.
fine. So let's start. Okay. So as I mentioned in our last session, in our study session, okay. So today we will start with the Llama and Llama 2. Okay, so this is the actually like one of the, I can say, famous model that we have in large language model developed by Facebook in Fab 2023. Okay, so let me open my Scribble and parallelly, it's not the RNN. RNN we can discuss later. Fine. So let me open little bit Llama by Facebook. So actually these are the some official documentation that we have. Okay, even I will show you the like research paper as well. Okay, so here we have the official paper, official documentation that is called Introducing the Llama, a fundamental 60 billion parameter large language model. Okay, so just see here that we have the 60 billion parameter. Now if I talk about little bit about the bot and GPT. So in bot
110 million.
110 million and in large
Yes, sir.
340 million. Okay, now if I talk about the GPT, so how many like parameter that we have here, model size in GPT? Yes guys? No, yesterday we completed this particular topic, right?
175 billion.
175 for GPT-3, 175 for GPT-3. What about GPT-2 and GPT-1? GPT-3 and GPT-1? Yes, Jaya.
GPT-1 124 million.
Okay, what about GPT-2?
2.15 billion.
2.15 billion. Okay, so now if I talk about the llama, so in llama that we have 65 billion parameter. So just see the differences in a model. Okay, so these are the old model that we have, like old and I can say the old model, not the basics, because these are not a basics model. These are the, I can say, super advanced model that we have in the field of NLP. Okay, so bot, GPT and all the GPT variants. And now in 2023, Fab 2023, Facebook released this particular model that is called Llama. Okay, Llama. So we can say here Llama stands for Large Language Model Meta AI. Okay, so let me put it on this one in this way. Yeah. So we can say Llama stands for Large Language Model, Large Language Model Meta AI. Meta AI. So large language model. So Llama, large language model, Meta AI. Okay, so this is the actually first generation, I can say first generation language model that we have released by Facebook, or we can see released by Meta in Fab 2023. In Fab 2023. Okay, it's like same, I can say same like the other model like GPT-3 and the GPT-4. Okay, but here in Llama, this is designed to focus on efficiency and flexibility. Efficiency and flexibility. So whenever like you are going to develop any types of the chatbot, you just need to write the few lines of the, I can say, the prompt, and based upon this one it will give you the entire things, whatever the things that you need. Okay, whatever the blog that you need to write, whatever the summary that you need to create, or whatever the content that you want to generate, anything. Okay, so here Llama, I can say, this is designed to focus on efficiency first thing, and the second thing that is called flexibility. Okay, so this is totally based upon the transformer architecture. As we know, like the foundation model that we have, that is called transformer, and based upon the transformer, that we have the entire other LLM, generative AI, and the SOTA NLP model that we have. Okay, so this Llama architecture is totally based upon the transformer architecture, and this is the lightweight that we have, lightweight model that we have, and this is suitable for research and the real world application. Whatever the real world application that you want to develop, like machine translation or text generation or the content generation, chatbot. Okay, so in these types of the application that we can use the Llama model. This is the lightweight and mainly, I can say, suitable for research and the real world application. Okay, so in a Llama that we have some core features that we have. Okay, so in Llama that we have some core features, so let's talk about those particular core features here. So core features of Llama, core features of Llama. Okay, so in core features, the first point that we have, that is called multiple size. Multiple size. Okay, so Llama model comes in a different sizes, ranging from 7 billion 7 billion parameter to 65 billion parameter, ranging between 7 billion parameter to 65 billion parameters. So now let's say that you have the, I can say, let's say if you are using the model from the Hugging Face platform, from the Hugging Face platform, and let's say in your local system that you have only 8 GB of the RAM, 8 GB of the RAM. So what you can do in this case, you can use the less parameter model like 7 billion, or the other models that you can use 7 billion, 13 billion parameters that you can use. Now let's say here, let's say if you have the GPU in your local system, or if you have, I can say, 16 GB or like 24 GB RAM, in this case you can go ahead with the higher model that is called 65 billion parameter. Okay, so here Llama, it comes with the different sizes. Okay, different sizes ranging from 7 billion parameter to 65 billion parameter. Second core features that we have here, that is called open research access. Open research access. Open research access. Okay, so Llama, this is designed for academic and the research purpose, as I already mentioned. So whenever we are going to do some types of the research, or whenever we are going to develop real time application, we can use a Llama model. Okay, so Llama, this is the open source access that we have. It means Llama, this is totally designed for academic and the research purpose, where researchers explore Llama capabilities, and then they train the various tasks. They can develop the real time application with the help of Llama model. So this is the second feature that we have, that is called open research access. Third point that we have, that is called optimized for the smaller machine. Optimized for smaller machines. Okay, so Llama has the multiple variants, as I mentioned. Okay, so we have, like in a Llama that we have the small variants, we have the large variants, large variants. Okay, so optimized for the smaller machines, it means Llama smaller variants can run in a like low grade hardware. Whenever we have the low grade configuration laptop or the configuration system, that we can use the llama smaller version to build our application, whatever the application that we are going to build for our industry, or whatever the research that we are going to do with the help of the llama model. Okay, so this is the third point that we have. And apart from this one more point that we have, that is called focused training. Focused training, it means with the help of llama that we can generate high quality text, high quality text that we can generate, and based upon those particular data, if we need, we can do the fine tuning for this particular llama model or whatever the other llama variants that we have, that is called llama 2. We can do the fine tuning. Okay, so llama model trains on the high quality textual data, so that whenever we are generating any types of the responses or the content, that we are getting the, I can say, the correct responses, first thing. Second thing that I can say, the complete summarization reports that we are getting. So let's say that we have the one research paper, and from those particular research paper, let's say if you need the summary, okay, let's say we have the like 30 to 40 pages research paper that we have, and for those particular 40 to 50 pages research paper, if you need the summary, easily our llama model, it will provide you the summary, and again in a proper manner, in a proper format, started with the abstract, again the definition, and the so on, whatever the points that we have, starting from number 1 to till the last pages. Okay, so in this way, these are the some of the core features that we have. First is a multiple size, second is a open source accessibility, third is a optimized for the smaller machine, and fourth, that is called focus training on the high quality data set. Okay, high quality data set. Now if I talk about little bit about the data set, okay, so if I talk about the little bit about the data set, so here like the organization, okay, like a Facebook organization, okay, Meta organization, as this particular model that we have from the Facebook itself, okay, so they have used the data from the different platform. Okay, so first thing first, like I can say the training data. Okay, so training data. Okay, so here the researchers, they have used 1.4 trillion tokens. 1.4 trillion tokens the researchers, the organization that is called Meta, they have used to train the llama model. Okay, now again they have used the data set from the various sources. Okay, various sources. So first sources, they have used the data from the common crawl. They have used approx 67% of the data from this particular website. Okay, from this particular website. Second thing, they have used the data from the GitHub. GitHub. Okay, so from the GitHub, they have used 4.5% of the data. 4.5% of the data they have taken from the GitHub. From the Wikipedia, they have used again 4.5% of the data. From the books, they have used 4.5% of the data. From the research paper, they have used approx 2.5% of the data. Okay, from the, I can say, stock exchange. Okay, so stock exchange, they have used 2% of the data. Okay, so these are the sources they have taken the data to train the complete llama model. So first is a common crawl, GitHub, a Wikipedia, books, research paper, and the stock exchange. So from here they have taken the data in a different percentage, 77%, 4.5%, 4.5%, and so on from the other sources. Okay, so from these two sources they have taken a complete data to train the complete model. Okay, to train the complete llama model. Now here as you can see, I mentioned one point that is called in llama that we have the multiple size ranging from 7 million parameter to 65 billion parameter. 7 million to 75 billion parameter. Now, so this is the range that we have, but in between that we have the multiple models actually. So now let me show you. So here model size, as we mentioned, starting from 7 billion parameter, I can say ranging from 7 billion parameter to 65 billion parameter. Okay, so first that we have, that is called 7 billion parameter. Second that we have, that is called 13 billion parameter. Third we have here 35 billion parameter, and last that we have that is called 65 billion parameter. Even if I show you on Google, okay, so model size for llama, different model size for llama is a llama 3, actually 8 billion to 70 billion parameter, but we are talking about here the llama. Definitely I will get something on this particular thing. So this is about the llama. As you can see, like it announced and released in the Fab 2023 3.2. I need something where I can show you the points. Whatever the, yeah. So as you can see here that we have the train on the llama 65 billion parameter. 65 is a 33, not a 35. It's a 33 actually. Sorry, it's a 33. First is a 7 billion parameter, second is a 13 billion parameter, and third is a 33 billion parameter. I can say it's a 33. Okay, so 33 billion parameter, and then last that we have that is called 65 billion parameter. So these are the different variants that we have, different model variants that we have, model size that we have, depends upon our use, depends upon our requirement. Let's say that we have the low configuration system, and if we want to do the llama training, in this case that we can go ahead with the 7 billion and 13 billion parameter. Now let's say if we have the high configuration system, we can go ahead with the 65 or the 33 billion parameters. Okay, so these are the some of the model size that we have. Okay, now let's try to understand llama architecture. So till here guys, can you please confirm, everyone clear? Yes,
Yes,
no?
sir. Clear.
Fine. Now after that we have the llama architecture. So let's talk about the llama architecture now. Llama architecture. So as we know, llama use the transformer architecture, which is, I can say, the neural network framework optimized to understand the sequential data like text data. Okay, so most of the things that we have seen, okay, as I can say the llama architecture, little bit differences that we have. Okay, so now let's talk about the complete architecture. So here if I show you, so I have one file. Okay, so in this particular file, as you can see that I have mentioned complete things. So large language model, Meta AI, okay, Llama 1 is the first version of the state of the art foundational large language model that was released in Meta Fab 2023. It is impressive collection of fundamental model comprised of the model with the parameter size ranging from 7 billion to 65 billion parameter. Llama 1 stands out due to the extensive training on the trillions of the token. As I said, 1.5, 1.4 trillion tokens the researchers they have used to train this particular model. Showcasing the state of the art models can be attended slowly through the publicly available dataset and without the need and the accessible data. Here we have the pre-training data. So common crowd, so English common crowd, the researcher they have taken. C4, they have used the data from the GitHub, used only for the Apache, BSD and the MIT license. Wikipedia, books data, research paper and the stock exchange. So from here the researchers, the organization, they have taken the data to train the complete llama model. Okay, to train the complete llama model. Now after that it covers the diverse set of the domains. For the most part we reuse the data sources that has been leveraged to train other LLM models. Okay, now let's talk about the complete complete architecture. Okay, complete llama architecture. Okay, so again it follow the our transformer architecture, where in a transformer that we have the self attention. So why we use the self attention? So self attention helps the model to focus on the most relevant parts of the input data, most relevant parts of the input data. After that we have the feed forward network. So it process and refine the input data for the further processing. Okay, now next thing that we have that is called like in a key component that we have, I can say the key component in a llama architecture, that is called tokenization or the tokenizer. Okay, so in a tokenizer what happened that we whatever the text that we have, we convert this particular text into the smaller piece, and then we say okay, so we have the tokens, we can say words, subwords or the characters. Whenever we convert the sentences, like I can say like in a one sentence, whenever we have the thousands word, or let's say 100, 500 words, and whenever we convert those particular data into the smaller piece, we can say we are going to convert the larger amounts of the data into the tokens. Okay, so we use byte pair encoding. Okay, byte pair encoding or some similar method to do the encoding. Okay, so here you just need to remember this particular point. So for the tokenization, for the tokenization, we use the byte pair encoding, that is called BP method, byte pair encoding. Okay, first. Second thing that we have, that is called input embedding. So what happen in input embedding, that we convert the tokens into the vector that our model can process those particular vectors, and then it will calculate the scores with the help of self attention, and then those particular scores that we can send to the feed forward neural network. Okay, so second step that we have, that is called input embedding, where we can use the input embedding to convert the data into the dense vector, whatever the data that we have, the tokens that we can say. Okay, so we convert the tokens into the dense vector. After doing the embedding, third step that we use the positional in positional embedding positional embedding. Third steps that we do the positional embedding. So we add the information about the order of the tokens in the sequences that is called positional embedding. After that, we use the attention mechanism. Okay, so self attention and the multi-head attention that we use. So self attention that we use to look at the relationship between the tokens in the same sequences, and the multi-head attention that we use, where we split the attention mechanism into a multiple heads to analyze the different, I can say, different aspects of the sequences, like syntax or context. Okay, so here we use the multi-head attention and the self attention. After that, whatever the output that we are getting from the self attention or from the multi-head attention, we send to the feed forward neural network. What happened in feed forward neural network? It processes the output from the attention mechanism. Okay, so whatever the understanding they have, based upon the understanding, we send the data like a score, I can say a score, to the feed forward neural network, and then feed forward neural network, it process the complete data, and after that it generate the out. Okay, now after that, next thing that we have, that is called layer stacking that we have in our architecture, and then our stacking, based upon the layer stacking, it generates the final output, that we can say the output layer, that predict the next tokens or complete the given text by generating one token at a time. Same thing that we do in our bot and GPT, right? MLM that we apply, mask language model, and NSP for the next sentence prediction that we use, right? So same thing that we have, little bit changes that we have in our architecture. So if I show you the changes, so first, as you can see, following the recent work on the large language model, our network is used on the transformer architecture. We leverage the various improvement that we are subsequently proposed and used in the different models such as palm. Okay, so palm, again, like that we can understand in our upcoming lecture what is palm and how the palm models works actually. So here are the main differences that we have in our original architecture. It means I'm talking about the transformer architecture. Okay, so first is a pre-normalization. Okay, so GPT 3, they use the pre-normalization. So to improve the training stability, we normalize the input of each transformer sublayer instead of normalizing the output. So in GPT, we normalize the output, but in Llama, we normalize the input of each transformer sublayer. Okay, and then we use the RMS normalization function to normalize the input data. So this is the first changes that we have in a Llama. After that, switch glue activation function that we use in a palm architecture, actually in palm model. Now what happened in Llama, we replace the ReLU for the non-linearity by the switch glue activation function to improve the performance. Okay, so we use the dimension of 2D, okay, and after that into to the 4D. It's not a 2D, do, and then 4D as in the palm. Okay, so this is the second modification that we have in our llama architecture. First is a pre-normalization that we do in a input embedding input data. Second, that we in change in a activation function. After that, we use the rotary embedding actually in GPT Neo. Okay, so we remove the absolute positional embedding. This is the embedding that we have in our, I can say, general transformer architecture. So instead of this one, we add the rotatory positional embedding. Okay, rope, I can say rope at the each layer of the network whenever we are going to do the embedding for our input data. Okay, so these are the some of the changes that we have, three changes. Now after that, next that we have the optimizer. Okay, so again, like we have changed the optimizer here as well. So our model are trained using the Adam W optimizer. Okay, with the following hyperparameters. So even we change some parameter as well. So these are the changes parameter that we have for beta 1 and the beta 2. We use the cosine learning rate schedule such the final learning rate is equal to the 10% of the mixing learning rate. Okay, so these are the changes that we have, and these are the changes that we have in our research paper. So based upon the research paper, actually I created this particular complete documentation. Okay, so first change normalization, second pre-normalization, second activation function, third is a rotatory embedding, fourth that is called embedding, and here that we have the implementation, how the complete implementation works for the llama. Okay, so yes guys, can you please confirm till here everyone clear architecture wise what are the changes that we have in a llama architecture based upon the previous one and the base architecture that is called transformer?
Clear, sir.
Yes, Ravi Teja, Jaya. Ravi Teja, Jaya, can you please confirm?
Yes, sir.
Okay, fine. Now after that, let's talk about the model size and the architecture actually. Okay, so how many attention head that we have, how many parameters that we have, how many hidden unit that we have, how many layers that we have. So let's talk about those things. Okay, so here let me create the line actually. Yes, so here I'm going to create the line. Let me create 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm going to like segregate everything. Okay, so here we are going to talk about the, I can say, model size and architecture. Okay, I know guys, see, it's a little difficult to understand because we are learning the complete research paper actually here. Okay, so that's why I said please focus on the session. Okay, now let's try to understand the model size and the architecture. Okay, so here that we have the model size, model size, we have the layers, we have a hidden unit, hidden units. Here we have the attention head, attention head, and here we have the parameters that I'm going to call. Okay, now let's talk about one by one. So first thing first, that is called, we have the 7 billion parameter model size. Here we have the 13 billion model size, 13 billion model size. We have the 30 billion model size, and here we have the last. It's a 30, it's not a 30, it's actually 33. 33 billion, and here we have the 65 billion model size. Now we have the layer. So here we have the 32 layer. Okay, here we have the 40 layer, we have the 60 layer, and we have the 80 layer. Now hidden unit, we have the, here we have it's a 7 billion, right? So 4096, we have here like 5120, we have here something called 33 now, so 6656. Okay, so there is some mismatch. Okay, so you can just find out on the Google as well. Okay, so you will get the hidden units actually. Okay, so based upon my like memory, I'm just writing here. So 8192 something like hidden unit that we have. Here we have the attention head like 32, 40, we have 52 and 64. 64, and this is 2. Okay, now after that parameter wise we have the 7 billion parameter, we have the 13 billion, 33, and here we have the 65. Okay, so these are the different I can say the model size that we have, and the different hidden units, attention head, and the layers that we have. Now these models that we can use depends upon our use or the application that we are going to develop. So whenever we are going to develop like I say lower application, or I can say whenever we have the lower configuration system, that we can use the lower model that is called 7 billion or 13 billion. Whenever we have the higher configuration system, we can use the higher model that is called 33 or a 35 billion parameter model. Okay, so these are the some of the different model size that we have. Now let's try to understand how the llama model is trained. Okay, how the llama models train. So how llama model trained. Okay, so here first point that we have, that is called data sources. Data sources. So llama, this particular model is trained on 1.4 million, 1.4 trillion token. Okay, 1.4 trillion tokens from the publicly available dataset, including books, article, and other sources from the other sources. Okay, now here whenever the researchers they took the data, okay, so they took the, I can say, the quality data. First of all, they did the complete, I can say, the filtering. Okay, they removed the complete noise and the low quality data, and after that they just selected only the high quality data. Okay, so they did the filtering, they did the like data cleaning, they removed the noisy data, they removed the low quality data, and after that whatever the good data set they got, they just used the high quality data, high quality data to build or to train the llama model. Okay, so this is the first point that we have. Second that we have here, second point, that is called objective. Okay, so llama is trained using the casual language modeling method. One method that we have, that is called casual learning. I can say no, it's not a learning, it's actually casual language, casual language modeling. Okay, so this is the method researchers they have used to train the llama model, which predicts the next word in a sequences based upon the previous word. So in bot we had one I can say application that is called next sentence prediction. Next sentence prediction. Okay, same way here in llama. Okay, researchers they have used the casual language modeling method to train the llama model, which predicts the next word in a sequences based upon the previous tokens, whatever the tokens that we have. Okay, and third point that we have here, that is called optimization. Optimization. Okay, so optimization, so here llama use the advanced technique like adaptive optimization to improve the training efficiency. Adaptive optimization to improve the training efficiency and then balance the performance with the lower computational model, whatever the lower computational model that we have, that is called 7 billion or the 13 billion model. Okay, 7 or 13 billion model, where that we need to balance the performance between our lower model and the higher model. Okay, so that's why here the researchers they have used the adaptive optimization to improve the training efficiency. Okay, so these are the three points that we have how the llama model train. So first is a data sources, second is objective, and third is a, I can say, optimization. Now, if I talk about the applications for the Llama, so we can build the chatbot, we can build the conversational AI system for the customer services or any virtual assistant like chatbots, content generation application like article, blog, or the storage, text summarization, so we can summarize the lengthy documents into the concise points. Okay, language translation, so from one language to the another language, code generation, so it helps the developer by generating the code snippet or the debugging the code. Okay, so these are the things that we have in our llama model. But again, whenever some model come into the market, it comes with some drawbacks or it comes with some challenges, I can say. Okay, everyone, till here, can you please confirm? Is clear?
Yes, sir.
Yes, sir. Clear.
Yes, sir.
Okay, fine. Now, as I mentioned, it comes with some challenges as well. Okay, so we have some challenges actually in this particular model. Okay, in this particular model, let me see. Do I have the in the documentation this particular point? Code generation. So yeah, as you can see here that I have mentioned like the reading comprehension that we can develop, code generation. So again, the researchers they have already tested this particular models. Okay, llama model on the different applications. So if I show you here, so let me go jump into the research paper. Actually, it's a little difficult to get the research paper for the llama model, but let me check if I will get. We have, but I don't know like where they have uploaded. Llama model foundation. Every time they change the like research paper summary part. Yeah, so as you can see here that we have the complete model. Okay, complete research paper. So open and efficient foundation language model. So first that we have here, as you can see. So if I show you the comparison, yeah, so as you can see like they have taken the data set from the common crawl 67%, same as I mentioned, right? C4 15%, GitHub 4.4%, 4.5%, Wikipedia 4.5, books 4.5, and so on. They have taken the data set from the different portal. Here we have the pre-training data. Okay, so we have the pre-training steps. So English data set, again the different books data sets. So they have collected from the different sources. Now here we have the llama model. Okay, so model size, architecture, and the optimization hyperparameter tuning that we have. So parameter by 6.7 billion, 13 billion, 32.5 billion. So we can say is 33 billion parameter. Okay, 65 billion parameter. Tokens by 1 trillion token, 1 trillion token, 1.4 trillion token, 1.4 trillion token. Batch size, these are the batch size that we have, learning rate, layers, heads, and the dimensions. Okay, dimensions, I can say the hidden state. Okay, and the same hidden state I thought like I have here as well. So 81926656. So yeah, same hidden state that we have. Okay, now here as you can see that we have the billions of the tokens, so different tokens and the training losses that we have. So llama 7 billion, llama 13 billion, llama 33 billion, llama 65 billion. So different losses that we are getting here. Here we have the architecture by, so pre-normalization, same thing I mentioned. Switch activation function based upon the palm, rotatory embedding GPT, optimizer. Okay, so here the like the researcher they have used the atom optimizer to do the entire training, where they have changed the parameter as well like beta and the beta 2. Okay, now after that, here we have the zero shot performance on the common sense reasoning task. Okay, so here we have the comparison between the different model. As you can see, GPT-3 on the different data set, Gopher, Chinchilla, Palm Count, Palm. So these are the different model that we have, and here that we have the llama model performance. Okay, llama model performance on the different task. Okay, so as you can see that we are getting 82 highest on the different model. Okay, so if you do the comparison between the other models, highest that we are getting for the llama. Again for this particular task we are getting the llama. Again for this one we are getting the llama 84%. For this one we are getting the palm. Okay, we are getting the palm. Now for this one again that we have the llama. Again for this one we have the llama, and so on. So most of the cases, as you can see, the llama wins in every scenario whenever they are developing the different, whenever they are testing with the different applications, okay, whenever they are testing with the different tasks. Okay, so that's why like mostly we prefer, okay, so let's say if you need the, I can say, open source model, if you need to do the implementation with the open source model, we usually prefer to use llama or mistral. Mistral, again, this is the one of the open source model that we have. Okay, so actually, as compared to the llama, easily that we can integrate with the Mistral. Okay, even if we have a lower configuration system, easily that you can do the integration with the Mistral. Okay, so these are the some of the open source model that we have. Okay, we usually do the implementation with this model. So let's say if the client say, okay, so we don't want a paid API like OpenAI or the any other API. Okay, in this case, that we can go ahead with the Llama or the Mistral models. Okay, because these are the easily available on the Hugging Face, and these are the open source, mainly for the research and the production ready application. Okay, so we can use these particular models to build the production ready applications. Okay, now after that, here we have the results on the different tasks. So main results on the zero shot, few shot. Okay, so these are the data set that we have, like the application that we have. Okay, task like common reasoning, common sense reasoning task. Okay, closed book question answering task, mathematical reasoning task. Okay, so the researchers, they have already tested this llama model on a different task. Okay, that's why I mentioned like we can develop the chatbot, or we can develop the content generation, text summarization, language translation, or the code generation types of the application to develop the llama model. Okay, now after that, here we have again like reading comprehension that we have, code generation. So these types of the application that we can develop. Here we have the again comparison between the different model, Palm, Mandvera, and the Llama. Again, here we have the comparison between the different models. So these are the some of the comparison actually that we have with the different models. Okay. Now here we have the again like multi-language task that we can do. So those things that we have, instruction fine tuning. So here we have the one interesting thing. Okay, so here we have the instruction like how that we can fine tune a particular model, whatever the model that we have. So how that we can fine tune the particular model, let's say that we are developing any particular application like code generation or the text summarization, okay, or any other models. Okay, so in this way, how that we can fine tune those particular applications. So those things that we have under the instruction fine tuning section. Okay, now bias, what are the bias that we have, it means what are the challenges that we have. So those things that we can talk about. So challenges wise, first that we have bias in the training. Okay, bias in the training. Okay, so like all language model, okay, all other language model like GPT, Palm, or whatever the other model that we have. So Llama biased from its training data actually. Okay, which can be lead to, I can say, incorrect, some not a incorrect, I can say, okay, problematic output sometime it will give you. Let's say if you are going to ask like okay, so like we are preparing for the JE IIT JE, and we are very frustrated with the syllabus and the government, whatever the rules that we have in the government. Okay, so in these types of the questions, so it might be possible sometime they suggest you to do the wrong things. Recently happens with the chat gpt, I thought chat gpt or the palm, no, it's with the palm actually. Okay, so Gemini model, one of the, I can say, like Pune, is a Pune or from the Maharashtra, one of their students asked something related to some career option. Okay, so Gemini suggest, okay, so do the suicide. Okay, so this types of the issue that we have in like llama actually. Okay, llama model. So first is it might be possible it will give you the probabilistic output. Okay, so where that if you have any types of the problem, it might be possible they will put it down in like on longer problem, I can say. Okay, and the second thing that we have, that is called ethical concern. Okay, so as the researchers, they have taken the data set from the open source platform. So as the platform is open source, okay, so any person, everyone, they have the authority, they can write anything on the Google or on the I can say books or in the GitHub or anywhere, whatever the sources they have taken. Okay, so that's why sometimes it's a ethical concern, they you can't get the, I can say, good content, I can say, or it might be possible it will provide you the misleading content or the harmful content. Okay, it might be possible it will generate the harmful content. Okay, so this is the some of the issues that we have. First is a biases, Second is a ethical. It might be possible it will generate misleading or the harmful content. Okay, so these are the some of the issues that we have in llama. That's why the researchers they published the next model that is called llama 2. Okay, llama 2. So these are the some of the issues that we have in llama 1. Okay, that's why we have the next model that is called llama 2. Apart from this one, real toxic prompt, so this is fine. Do we have any cross pair window chair? Fine. Truth, yeah, so these are the some of the evaluation technique the researchers they have used. So truthful QA, window gender. Okay, so these are the evaluation metrics that we have in a LLM model actually. Okay, so these are the method they have used to evaluate the particular model. Now related work, carbon footprint, architecture. Yes, so these are the things that we have, guys, in our llama. Okay, so these are the things that we have in llama. So can you please confirm till here, guys, llama part is clear or is it confusing?
Yes, sir.
Little bit confusing. Yes,
Yes, sir.
Teja?
It's confusing.
Yes.
So, is it true that a student that asked that question is given the
Yes,
wrong?
yes, yes, it's true, ma'am. It's true, actually. Okay, so it's like I can say 10 to 15 days old news that we have. Okay, so
Yes.
one of the Maharashtra or the Mumbai-based student, he asked some career-related questions, and the Google said, okay, so do the suicide. Okay, so it's a true news actually. Okay, that's why like in every platform, like in I can say Microsoft Copilot and Gemini, as well as in Chat GPT even. Okay, so they have now the feedback section, and whenever you log in first time, okay, so they will give you the warning. Okay, so don't blindly trust on this particular platform. They will give you the warning whenever you I can say whenever you join first time, Chat GPT or the Gemini or the Microsoft Copilot. Okay, so it's already happened. It's like it's a 10 to 15 days old news. Even when you search on the Google, you will get the some article. Okay, so it's like correct news actually. Fine. So these are the things that we have in Llama. Okay. Now let me tell you a little bit about the Llama 2 as well. Okay. So these are the things that we have in Llama. Okay. So you just need to remember this particular point. Whatever the optimization that we have, whatever the modification that we have in Llama as compared to other models. So first modification that we have pre-normalization. Second that is called activation function. Third rotatory embedding. Fourth that is called optimization. These things that you need to remember. Apart from this one, just remember the like different model size, whatever the different model size that we have, because whenever you are going to do the implementation, you can just select the model depends upon the requirement and the configuration that you have. Like the let's say that if you are using GPU, definitely you can go ahead with the higher model. If you have the CPU only, definitely you can go ahead with the lower model that is called 7 billion, or I can say 13 billion parameter. Okay, got it everyone?
Yes, sir.
Okay, fine. Now let's try to understand a little bit about the this model like llama 2. Okay, let's try to understand a little bit about the llama 2. Let me open what, let me check, do I have any seat here or not? Hmm. Llama 2, yeah, it's updated version is fine. So yeah, fine. So let me explain. I will add in this particular file later after the session. Okay, fine, guys. So let's understand the llama 2. Okay, so actually llama 2, this is the again I can say the updated version that we have for the llama. Okay, updated version that we have for the llama, and again it developed by the Facebook itself, as they have the second version for the llama. Okay, so let's understand first of all some key features of the llama here. Okay, so first key features that we have in llama, that is called open source. Again, this is the open source actually. Open source. Open source, it means like this is openly available for the research and for the developer as well. Okay, so the previous one available only for the I can say research and the commercial purpose. It means the paid one. But this llama 2 is available for I can say research plus developers. Anyone they can access this particular application. Okay, now first is open source. Second that we have the model size. Second point that we have here, that is called model size. So again in llama 2, we have the multiple model size that we have. First that we have, that is called 7 billion parameter. Sorry, it's a 7 billion parameter. Second that we have, that is called 13 billion parameter. And third that we have, that is called 70 billion parameter. If I'm not wrong, we have only three version: 7 billion, 13 billion, and 7 billion parameter. Yes, only three variants that we have. Okay, again depends upon our requirement that we select the different variants. If we have the lower configuration, that we can select lower one. If we have the higher one, we can select the higher one. Okay, now third point that we have, third key features that we have, that is called pre-training dataset. Pre-training dataset. Okay, so again llama 2, this is trained on the 2 trillion token. Llama 1 trained on the 1.4 trillion tokens. Llama 2 trained on 2 trillion. Yes, 2 trillion tokens from again publicly available data, whatever the publicly available data set that we have. So the researchers, they have taken the same data, same types of the data. Apart from this one, they have done the same thing, whatever the data cleaning and the unwanted data removal they have used in a llama 1, same thing they have done here as well. They have just selected the high quality data set to improve the performance, or I can say the generalization for this particular model. Okay, so this is the third point that we have, pre-training, where the researchers, they have taken 2 trillion data set. Now fourth that we have, that is called fine tuning. Okay, so llama 2, this model can be fine tuned for any specific task and the industry where that we can develop our custom application, any custom application where we can fine tune this particular existing model. Okay, now after that we have the next one, that is called optimized architecture. Optimized architecture. Okay, so here again the researchers, they have used the base architecture, that is called transformer, but they have updated some of the point, some of the things they have updated to improve the training stability, speeds, and memory efficiency. First point, first they have changed the like architecture, where they have changed because of the stability, I can say the training stability. Second for the speed, and third for the, I can say, memory efficiency. Okay, so these are the things they have done in a optimized architecture. After that, sixth point that we have, that is called chat model. Okay, so the llama 2 includes the chat model version, that is called llama 2 chat. Whenever you search on the Google llama 2 chat, okay, so this is the llama 2 chat. Okay, llama 2 chat. Okay, so llama 2, yeah, so this is the model that we have. Even this is publicly available on the Hugging Face as well. We can just call the model from here, and then we can use whenever we are developing the application. Okay, so these are the some of the key features that we have. Okay, so key features that we have in our llama 2. First one, that is called open source. Second one, that is called different model size. Third, pre-training data set. Fourth, fine tuning. And the fifth, that is called optimized architecture. Okay, now if I talk about how the llama 2 works, okay, so llama 2, this is based upon the transformer architecture. Okay, it follow, I can say, the complete transformer architecture. Okay, first thing here that we have, that is called attention mechanism, that process the input sequences by focus on the relevant part of the text. Second that we have, that is called position embedding. It helps the model to understand the order of, I can say, order of words in a sequences. Then we have the multi-head attention, that enhance the model ability to capture the complex relationship in a data. After that we have like layer normalization, that we use for the speed up training. And then we have the dense layer, that we use to for the both global and the local context understanding part. Okay, so same thing, whatever the architecture that we have in our like transformer, same architecture that we have in our llama 2 as well. Okay, same architecture that we have. Now if I talk about the application wise, okay, so we have the conversational AI application that we can develop, content creation, code generation, language translation, research assistant. So these types of the application that we can develop with the help of llama 2 model. Here we have some again like challenges, same challenges, ethical concern. Okay, so it might be possible it will provide you harmful or the misleading content. Sometime resources requirement and the biases of the data. Okay, so as llama 2 is a large language model, so it might be possible its biases for the particular part. Let's say if you are going to ask some question related to Facebook. Okay, Facebook and some other platform like LinkedIn, if you are going to do the comparison, so it might be possible it biased on the Facebook as this is developed by the Facebook. Okay, so it might be possible sometime it will give you the biases responses. Okay, so these are the things that we have, only that you need to remember the parameter size. So three different parameter that we have: 7 billion, 13 billion and 70 billion parameter. Apart from this one, same training size that we have and same training size. And if I talk about the optimization part, so little bit optimization researchers they have done. So if I show you llama 2 research paper, this is for the chat model actually. I need something else. Let me see if I will get download the research paper. Yes, so let me show you the safety RLHF. Yeah, so as you can see here, they have used the supervised fine tuning for the fine tuning method. Even they have the RLHF. RLHF that is called reinforcement learning with the human feedback. So what happened whenever we are using the chat GPT? Okay, so whenever we are using a chat GPT, so sometimes what happen, let's say if we are getting the wrong responses or as for the expectation, let's say if we are not getting the output, then what we say the chat GPT, okay, so give me the output in this way or that way, right? We usually ask the chat GPT, right? Or we say, okay, so I'm getting the wrong responses, please optimize the code or please give me the correct code. So what happened, chat GPT understand and it learns based upon the user feedback. So as we are going to say, okay, this is the wrong, like this code gives us the wrong responses, I'm not getting the expected output. In this case, we are providing the feedback to the model, and then our model chat gpt understand those particular feedback, and then again it generate the next output, again it generate the next output. So here as you can see, RLHF, so reinforcement learning, it means based upon our feedback our model it learns and then it will give us the final output. If I show you, so actually recently I used this particular platform that is called this one, Cloudy AI. Okay, so I hope I have something here, so let me show you. Yeah, so as you can see, like I actually today morning actually for the YouTube actually I created one application that is called CSB data analysis dashboard with the LLM. Okay, so what happened, like when I asked to create the complete application, so sometime it gives us the error, so I resolve it. But after that what happened, like whenever we are going to load here, so as you can see in this particular code it load the, like it's say the, okay, so initialize your API key in this particular file main dot or the application.py file. Okay, but what I usually do, I upload my API key in .env file. So I said no, load from the .env. Okay, so I just said, okay, so load from the .env what, our API key. Then again it generates the code and then it loads the API key from our .env file. Okay, so in this way we usually provide the feedback to the model. Again models learns from our feedback and then it gives us the output. Okay, so this is called actually reinforcement learning, where models learns based upon the human feedback and then it will give you the responses. Okay, so in this way that we can do the fine tuning for the llama 2 model. Here we have the safety and training. Okay, now one thing that I need to show you here in this particular research paper, so this is the violation that we have lower is safer. So as you can see here that we have the different comparison. Okay, so chat gpt, okay, so here llama 2, okay, so llama 2 7 billion, 13 billion, 34 billion, 70 billion. And here if I talk about the violation, it means the, like I can say the misleading output most of the time that we are getting in this particular model, that is called vicuna and palm, and less, I can say less misleading output that we are getting in a llama 2 13 billion and llama 2 7 billion model. Even in chat gpt that we are getting the misleading responses. As you can see here we have the higher one, these are the lower one that we have. So these are the comparison that we have between the different model. Okay, so here we have the different models. So Llama 2 and the Llama 2 chat. Okay, so Llama 2 chat that we can fine tune, where that we can optimize for the like chatbot building. Chatbot building, it means like whenever we are going to build a code related chatbot application. Okay, now here we have how the like reinforcement learning, how the fine tuning works, how the pre-training works. So pre-training based upon the data that we train the LLM model. After that we fine tune for the specific task. After that, based upon the human feedback, our model learns and then it will give us the final output. Now here you can see pre-training that we have pre-training, training details, hyperparameter tuning. So again, sorry, I jump into the last one directly. Yes. So here you can see like here we have the our training corpus includes the new mix of the data publicly available from the sources. 2 trillions of the data, okay, from the different sources. Here again like RMS normalization. So same thing as in the our like Llama 1, okay. Swig activation function, rotatory positional embedding, same thing that I have mentioned. Rope, okay. So same thing, whatever the things that we have in a like Llama, same thing that we have in our Llama 2 as well. Hyperparameter tuning. So again, Adam optimizer, same thing that I've mentioned in my seat as well. So we are using the Llama like Adam optimizer here. So optimizer, Adam optimizer, beta and beta 2. Same thing that we have in this particular research paper as well. Okay, so Adam, where beta 1 that is called 0.9, beta 2 that is called 0.95. Okay, same thing as the Llama 1 that we have. Hardware wise, so these are the training point that we have. So what are the hardware researchers they have used to train this particular model? Here we have the different evaluations. So code, common sense reasoning, world knowledge, reading comprehension, and the math problem. Overall performance that we are getting here, comparison between MPT, Falcon, Llama 1 and Llama 2. So here you can see the performance between the other models. So always Llama 2 performs well on the different data. Now here we have the fine tuning process actually. So SFT that we can use first is a supervised fine tuning method that we can use for the fine tuning. Okay, and the second one that is called RLHF. Okay, so this is the two technique that we have actually to do the fine tuning. First is a supervised fine tuning and second is a SFT. Okay, so yes guys, this is all about Llama and Llama 2. Okay, so I just give you the like glimpse about the Llama and Llama 2. Okay, in depth we have the many more things. Okay, if I talk about the SFT, so again SFT, this is the again big topic that we have in LLM. Okay, so if I talk about the SFT, so it will take approx 2 to 3 hours to explain only the SFC. So that's why I just give you the glimpse, okay, so that you can understand. Okay, so these are the things that we are doing in Llama and Llama 2. Okay, so later part, whenever you want to explore, okay, so you can just explore the research paper, okay, and even like I will provide you the complete like doc file as well. Right now it's not ready, but I will share, okay, later part, like definitely in next 2 to 3 days I will try to update this particular sheet so that whenever you want you can just go through this particular file and then you will get the idea. So as you can see that I've kept it the link from the like medium and the research paper. Usually I follow the research paper because on the research paper that we are getting each and everything on the one places. Okay, so I follow this one. So yes guys, this is all about the Llama and Llama 2. Let me know if you have any doubt, anyone, in an overview only. Yes.
So yes, sir.
Yes ma'am,
Right now
please
we
tell me.
don't have. So whenever we have, definitely.
Okay, fine. No issue, ma'am. So actually, like right now, I just give the glimpse, not in a
Yes.
detail. Okay, because we have the many more things in a Llama and Llama 2. Okay, so just think like the Facebook, they took 7 months to develop one model that is called Llama, that we can't learn in 1 hour, right? So we have many
Yes.
more things under this one. Even if I show you the like what I can do, I will upload one implementation video related to Llama where I already explained the complete codes. Okay, so I will upload one video on the like in our seats, so you guys can just go through it the video. Okay,
Okay.
so
Okay.
if you face an issue again, like I'm here in a group, we can connect anytime, depends upon the query. And
Yes.
next session again one more model that we can understand. So let's understand the Mistral actually, not a Palm. Okay, because we usually use the Llama or the Mistral model. Okay, so let's understand the Mistral model.
Okay, sir.
Okay, fine. Ravi Teja Jaya.
Yes, sir.
Okay, Fine, guys. So yes, this is all about the today's session. Let's conclude here. And next session that we can cover one more topic, one more models that is called mixture. Okay. Again, we can understand in detail, and then we can conclude this course here. Okay.
Thank you, sir.
Okay. Yeah. Okay, guys. Fine. Thank you. Thank you, guys. Yeah.
Thank you, sir.